Good morning, everyone. Myself, Professor Rajendra Ghivari from Department of Electrical and Electronics Engineering. Today, we will be looking at Module 2, which is Fast Fourier Transform. The contents of this chapter are: what is Fast Fourier Transform, Decimation in time, DIT FFT butterfly structure, signal flow graph for radix DIT FFT for n is equal to 4 value, and one numerical on DIT FFT. Let's start. Fast Fourier transform is highly efficient procedure for computing DFT of finite series and requires less number of computation, less than that of direct evaluation of DFT and inverse DFT. FFT is based on divide and conquer algorithm when you divide the signal into two smaller signals. Then compute the DFT of those two smaller signals and join them to get the original DFT signal. FFT is generally an algorithm used to compute the DFT. So FFT is more faster compared to TFT, where in FFT there is a divide and conquer algorithm which is taking place. You are dividing that signal into two smaller signals. Again, you are computing the DFT of those two smaller signals and joining at the end, you are joining them to get one DFT of a large signal. Right. So in FFT, there are two parts. One is decimation in time, that is DIT FFT, and the second one is decimation in frequency, DIT FFT. The shortcut, the short brief of DIT is DIT FFT. So let's start with DIT FFT. DIT, that is decimation time. The idea is to break the endpoint sequence into two half-length DFTs of the even index and the odd index time samples. You'll be having one endpoint sequence. You're going to divide that endpoint sequence into two halves. One will be of even index and the other would be of odd index samples. Initially, the endpoint sequence is divided into n by 2 point sequence, that is x even of n and x odd of n, which have even and odd number of x of n respectively. We will see when the structure is for the next slide. Now, n by 2 point DFT of these two sequences are evaluated and combined to give an n point DFT. It is as similar as what you are solving a problem for a DFT, wherein its formula is x of k is equal to summation n is equal to 0 n minus 1 x of n w n kn, where the value of k is ranging from 0 to n minus 1. So the same case or the same equation is been transformed to an algorithm by using an FFT, that is fast Fourier transform. Now in DIT FFT, the input simples x of n appears in bit reverse order and the output sequence x of k appears in a natural number. Right? Next. DIT FFT butterfly structure. So this is the butterfly structure of an DIT FFT. Right? Now you need to draw two lines. Right? The first line is A, the second one is B. Put an X mark between these two lines and put the arrows accordingly to the structure. This is the structure you need to maintain when you are solving the problem, compulsory. Now at the second line, initial of B, you need to write WNR. Okay. Now how do you get this expression A plus B WNR? So when you want to get this, you can see this, the value of A has come here. So to this point, there is also this line coming, which is an addition point. It is like in KCL, you can say current meeting at one junction, right? So you're adding, so it could be like, so A plus B into WNR. Similarly, for the second one, you're getting A at this point initially. At the same time, you have a minus sign here. So minus of B into WNR. I hope you can understand the butterfly. A and B, right? Give the arrows accordingly. Write minus 1 over here, write WNR. For this, it is A plus B into WNR. Here it is A minus B into WNR. This is the butterfly structure where you have to remember in order to draw it. Next. Now, this is a 4-point DFT. We have 4-point, we have 8-point, we have 16-point DFT also, right? So if we have 4-point DIT, we have 4-point, if we have 8-point DIT, we have 16-point DIT. Now, when we want to solve a problem for a 4-point, saying that signal flow graph for radix DIT FFT n is equal to 4. We call this as radix DIT FFT n is equal to 4. So we need to look at the same structure and draw the signal flow graph for DIT FFT, right? So draw 4 lines, okay, and look at this part. This structure is almost similar to what you have drawn here, the butterfly structure. Between these two lines, draw a cross. Between these two lines, draw a cross. And make sure that this is your input now. This is your x of n value, small x of n value, and which are in bit reverse order. X of 0, x of 2, x of 1, x of 3. Small x of 0 it is. And the output is of capital X of 0, x of 1, x of 2, x of 3. They have here they have written as f, right? So this is according to the butterfly structure. So this is my first structure. Second structure is wherein I am going to draw one x, right? So I'm going to join this x of 0 and x of 1 and x of 1 and x of 0 to make one x. Second I have to draw another. Secondly, I'll be taking one more x from x of 2 and x of 3 to make one more x. So the same structure should be observed with respect to this butterfly structure. Okay. Now you can see here, this is my butterfly structure. This is A plus B into WNR, A minus WBNR. So this is my first x. This is my first stage, you can say, right? So this is my input, x of 0. Its output, DFT of x of n is what? Capital X of k. Therefore x of 0, uska input kya hai? x1 of 0. Similarly, x of 2, its input is x1 of 1. Why? As I said, for a DIT FFT, always the input will be bit reverse order. The output will be a natural number, 0, 1, 2, 3. Here 0, 2, 1, 3. So compare these two structures. So it is almost similar. Alright, okay. Now looking at this stage, now join x of 0 and x of 1 and x of 0 and x of 1, so that can get one single x. So you'll get x2 of 0 here, you'll get x2 of 2, and similarly 1x over here. And whenever you're drawing x over here, make sure that you're giving minus to this particular x, and you're going to add W40. There's one more x. At the end of the line, you're going to give minus 1 and you're going to show W4. It is just like a Rangoli. Okay, it's very simple and very important chapter. Now, we'll be looking at the relevant equations. So here, in order to calculate x1 of 0, so here what I have seen is that it's A plus B WNR. So if I want to calculate the x1 of 0, my answer is x1 of 0 is equal to x of 0 plus x of 2 into W40. X of 0 plus x of 2 into W40, which is similar as to this. Now if you want to write x1 of 1, it is simple. Just need to change that plus to minus over here. So the answer would be x of 0 minus x of 2 into W40. Similarly, in order to calculate x1 of 2, x of 1 plus x of 3 into W40. x1 of 3, x of 1 minus x of 3 into W40, which you can see over here. So the first stage is very easy to calculate and write. Even the second stage is very easy. Now, you should be very careful in calculating this part for the second stage. Now I need to calculate x2 of 0, capital X2 of 0. So look at x2 of 0, which all points are, or the arrows are coming at this point. So I have whatever answer you're going to get, x1 of 0, x1 of 1, x1 of 2, x1 of 3, these will be the inputs for these lines now, right? Whatever answer you're going to get will be the same answer for these lines. So x2 of 0 is obtained by x1 of 0 plus x1 of 2 into W40. I'll repeat once again. In order to obtain x2 of 0, it is x1 of 0 plus x1 of 2 into W40. Right? Now, so this is one equation. x1 of 0 plus x1 of 2 W40. So I'll take the next line of this. I'll take the next line of x. I will not go for x2 of 1. Why? Because my x are lying on x2 of 0 and x2 of 2. Therefore, in order to get x2 of 2, it is x1 of 0 minus x1 of 2 into W40. Just need to change the sign. But here, it will be x2 of 0 and x2 of 2. Similarly, in order to calculate x2 of 1, I'll take x1 of 1 plus x1 of 3 into W41. And to calculate x2 of 3, which is remained, is x1 of 1 minus x1 of 3 into W14. So these are the equations. If you can understand the butterfly structure, this is one single butterfly structure of DIT FFT. If you can understand this part, you can draw the signal flow graph for radix DIT FFT n is equal to 4. And similarly, you can draw it for n is equal to 8, which will be looking at further classes, for the further lectures, you can say. So now let's go ahead with the problem. Now, looking at the first module, which is DFT, usually we'll be getting a question as compute 4-point DFT of the sequence x of n is equal to 1, 0, 1, 0. You either go by matrix method, you either go by the formula of x of k is equal to summation n is equal to 0, n minus 1, x of n, w n k n. So it is a similar part. We have inputs of x of n. We are going to find the DFT of x of n. So DFT of x of n is what? X of k, capital X of k. So here compute 4-point DFT of the sequence x of n using DIT FFT radix 2 algorithm. So this is my butterfly structure right now. So what we have seen through. Now, so again, you need to draw, as it is for 4-point, we need to draw the same structure for 4-point with same arrows. You should always remember that you should draw an x with all these arrows with minus 1 wn, which is a trivial factor. I hope you remember, right? Now, so as I said, the input will be in bit reverse order and the output will be in natural numbers. So the input is small x of n, the output is x of k. Why? This is DFT of x of n. We are finding x of k. So x of 0 is 1, x of 0 is 1, x of 2 is 1, x of 1 is 0, x of 3 is 0. Okay. So substitute the values. Draw the structure. You need to give the arrows over here also. Right. Now in order to find x1 of 0, it is x of 0 plus x of 2 into W40. Am I right? X1 of 0 is equal to x of 0 plus x of 2 into W40. X of 0 plus x of 2 W40. So you know the value of x of 0, which is 1. You know the value of x of 2, which is 1. Even you know the value of W40 as the value as 1. So it is 1 plus 1 into 1 is 2. Similarly, you need to calculate x1 of 1. So which is x1 of 1 is equal to x of 0 minus x of 2 into W40. X of 0 minus x of 2 W40. So you just need to change the minus only for first stage, which will be easy. If you can get first x1 of 0, you can write x1 of 1 by just changing the minus sign. So W40 is 1, 1 1 is 1, you are getting the answer as 0. Similarly, x1 of 1 and x1 of 2, x1 of 3 can be easily calculated, I hope. Now, whatever answer you're going to get here will be the inputs for these lines, right? So draw X mark, give the arrows. You are going to give arrow here, and you're going to give arrow, one arrow at this X. I'm going to write minus 1, W40. Here, second X, minus 1, W4, 1 here. So in order to calculate x2 of 0, if I want to calculate x2 of 0, it is x1 of 0 plus x1 of 2 into W40. And if I want to calculate this x part is ending over at x2 of 2. So x of 2 is equal to x1 of 0 minus x1 of 2 and so on. So you can see all the calculation part I have done. So if you can understand this butterfly diagram, and accordingly you can draw the signal flow graph for n is equal to 4 length. This is the exact picture where you can easily download, or you can refer the diagram and draw it and solve the problem. And few more problems will be solved for the next classes.